Integration by parts. From the beginning of 2000 to the beginning of 2007, the United States consumed gasoline at the rate of about Q of T equal to 2.0 T plus 131 billion gallons per year, for T between 0 and 7 inclusive. T is the number of years since 2000. During the same period, the price of gasoline would approximately P of T equals 1.2 e to the 0.11 T dollars per gallon. Use an integral to estimate the nearly $10 billion the total spent on gasoline during the given period. We were given Q of T, whose units is billion gallons per year, and P of T, whose units is dollars per gallon. If we take Q of T times P of T, then we end up with the unit that is billion of gallons per year. That is the unit of Q of T times dollars per gallon. And the gallon canceled out. We will end up with billion of dollars per year. Now we are looking for the total spend, meaning we're looking for the dollars amount during the given periods. That is, we're looking for $1 billion alone. Given that this product is a rate, to get the quantity in billion of dollars alone, we would need to integrate this quantity. What this means is that the answer will be the integral of Q of T times P of T dt, where Q of T is 2.0 T plus 131 and P of T is 1.2 e to the 0.11 T, don't forget dt. And we will do this by integrating from 0 to 7 because we're looking for the total spend during the given period from 0 to 7, the year 2000 to the year 2007. First, we need to find an antiderivative of the integrand. The integrand, the quantity 2.0 T plus 131 times 1.2 e to the 11 T is a product of two factors. The first factor, 2.0 T plus 131, is what we call an algebraic factor, and 1.2 e to the 11 T is an exponential factor. Because the integrand consists of algebraic and exponential, we're going to use integration by parts. But in this case, we're going to use the shortcut, the table method. On the left-hand column, we will put the algebraic factor 2.0 T plus 131. And in the right column, we put the exponential factor 1.2 e to the 0.11 T. On the left-hand side, we successively taking derivative. Derivative of 2t plus 131 is 2. Derivative of 2 is 0. On the right column, we successively taking the antiderivative. 1.2 is a constant multiple, so we rewrite it. And antiderivative of e to the 0.11t is e to the 0.11t divided by 0.11. 1.2 divided by 0.11 is now a constant multiple, so we rewrite it. And antiderivative of e to the 0.11t is e to the 0.11t divided by 0.11. Simplifying this, we'll get 1.2 e to the 0.11t over 0.11 squared. Don't forget to alternate the sign, plus, minus, plus, where we will multiply diagonally to obtain the answer. And the last one, we didn't have to find the antiderivative of this expression because 0 times anything will be 0. And so the antiderivative will be the first product of the first diagonal. 2.0t plus 131 is 2t plus 131 times 1.2 divided by 0.11 e to the 0.11 t minus, remember, alternating the sign, plus, minus, 2 times 1.2 e to the 0.11 t divided by 0.11 squared, plus, there's no need to write it because 0 times anything will be 0, and we evaluate from 0 to 7. There are two expressions that we will need to evaluate. The first expression, plug in 7, and the second expression, plug in 0. What this means is that we plug in 7, we will get 2 times 7 plus 131 times 1.2 divided by 0.11 times e to the 0.11 times 7 minus 2 times 1.2 divided by 0.11 squared e to the 0.11 times 7. And then we evaluate this expression. For the second expression, we will plug in 0. So 2 times 0 plus 131 times 1.2 divided by 0.11 e to the 0.11 times 0 minus 2 times 1.2 divided by 0.11 squared times e to the 0.11 times 0. And then we evaluate this expression. Remember that e to the 0 power is 1, not 0, so this will not disappear. Once we evaluate the two, we subtract them in this order, taking the first minus the second, and use a calculator. We will get approximately 1,757. The unit is in billion of dollars. If we round it to the nearer $10 billion, then it is approximately $1760 billion.